All right, so yes, this is one of the alkenes. All right, we have a double bond right here. Okay, we have 1, 2, 3, 4, 5 carbons, so that's a pent prefix. Okay, and we have an ene suffix. Okay, notice I'm leaving a space here, and there's a reason for that. All right. After the carbon chain is longer than 3 carbons, if the carbon chain is longer than 3 carbons, we have to use a numbering system to tell the reader where the double bond is located. Okay? So now what we want is the lowest number, 1, 2, or 1, 2, 3, the lowest number to the most important functional group. Well, right now that's the only functional group. Okay? So this is going to be 1, 2. Pent, 2-ene.
But how are we going to know where to put it? I mean, I know that.
You're going to put the double bond on the second carbon going to the third.
Does it matter what side?
Either side is the exact same.
Then you still number it. It doesn't matter which end you start with then, does it? Right?
So you can only go 1, 2, 3, or 4 on that? You can only be as
True. Well, actually, you could only have it on 1 or 2, because if it's here, you're going to number from this side. That's smaller. It can only be either 1 or 2 here.
So, okay, so it'd be 1, 2, 1.
Yep. That's it. Yes.
Okay, so assume like the other double bond there was like 4 or 5 carbons,
Mhm.
and the least amount was on this side. Would it be like? Would you count?
You number to the you number so that you get the smallest total numbers to the most important functional group, whatever that happens to be. Okay? Now I've made it easy for you, because in your test references on your list of functional groups, they're in order from least important to most important. Okay? So figuring out what's the most important functional group is all a matter of starting at the bottom until you hit the functional group, one of the functional groups on your structure. Okay? Yes?
So an advanced alkene is always going to be a number in there?
No. I'll be back to that in a second. Yes?
Why do you only put it from the second to the third?
Well, I'm numbering from this side, so that gets me the smallest number to the most important functional group. So I hit it, if you could say, at the second carbon. That's why we number it there.
Wait, I thought you said well, what if it's already written down and we have to draw it?
Then that's what you do. You say, okay, I've got a double bond on the second carbon, 5 carbons, put the double bond on the second carbon.
So if you have more than one.
Well, we'll get to that too. Okay? All right? So somebody asked, does this only apply, do we always have to have a number anytime there's a double bond? The answer to that is no, and I'm going to show you why. Let's see. Okay. Question. What is the name of this thing? We're going to use a numbering system. You call it 1-propene, wouldn't you?
Yes.
Okay. What if we do this? It's still 1-propene. It hasn't changed.
One's in front of it?
So we don't need a numbering system if we only have 3 carbons. If you were to look up the name of this chemical, in almost any textbook, it's not going to say pent-2-ene. It's going to say 2-pentene. Normally, when we have really simple structures like that, we put the number out in front. But later, with more complex structures, we have to stick it in the middle. Rather than mix up those things for you right now, to keep it simpler, we're just going to name it this way because that will hold true no matter what kind of structure we're naming. Okay? This will make it simpler over the long haul. Does that answer your question? Carson?
Yes, it does.
Okay. All right, so any organic chemist will know what you mean if you write it like this. Okay? But when you get to college, you're going to be expected to say 2-pentene instead. But there are times when you can't put the number in front. It won't work anymore. Okay? So rather than mix up those two different systems, we're just going to always stick the number in the middle for right now. Okay? We're always going to put the number in front of the functional group to which it applies. Okay? We're always going to put the number in front of the functional group to which it applies. Does that make sense?
So even is the functional.
That double bond is a functional group. Okay? It's also called a substituent group, but let's don't mix up those terms either.
Let's not do
Okay? All right. There are some functional groups that are substituent groups and some that aren't.
Okay, so you put a number in front of what? Say it again.
In front of the functional group to which it applies. Okay, let's do a condensed structural formula real quick. All right, so that's a condensed structural formula. And there's a skeletal structural formula. And there's another skeletal structural formula for the same thing. And there's another skeletal structural formula for the same thing.
Why would you start from that way?
You start from whichever end of the chain gets you the lowest numbers to the most important functional group. So all I did was flip them around. Okay? Well, 1, 2, 3, 4, 5 carbons, and the double bonds on the second carbon. Any way you do it.
On the first one.
1, 2. Lowest numbers to the most important functional group.
You're not going to require us to do like
No, if I ask you to draw it, you can draw it any of the way that'll work for you. But if I give you the drawing, you got to know how to name it. Okay? Yes.
So when you do the in like, on the chart, it has like the ring and it has like the bonds, like in the ring.
Mhm.
Is that like three double bonds?
Oh, we're going to get to that. That'll be just hang on. Yes.
like on the complete circle one, the double bonds over 2 carbons, but on the skeletal right there, there were 1, 2, 3.
But only if you number it from this side. You number it from this side, and it's on number 2. And you always number from whichever end gets you the lowest numbers.
But on the complete one, if you number from that way, it's
But it doesn't matter. All I did was flip it over.
so like you can also draw it like that, but with that little line over to the other side.
Sure. Sure. So if you're standing up, or if you're standing on your head, you're still Clint, right?
Well, that's my last name.
Yeah. Doesn't matter whether you're standing on your head or all we did was turn these around. Okay? All right. Yes.
The right side up is starting and going down and then zigzagging.
Now what?
Both.
Watch the video tonight.
Both pictures are
Well, you'll get used to. I hope you're going to get used to it. This is what you have to learn to think. How you have to learn to think to do this.
so if it starts down and then if the zigzag starts going up, then
It doesn't matter whether your zigzag starts going up or starts going down. Either one's fine. Or goes sideways.
I'm talking about where to put the double bond.
Always, it doesn't really. As long as I only have one double bond, as long as it's on the second carbon from one end to the other, it doesn't matter. Because you're going to number it from the end that gets you the lowest numbers overall. Okay? Now we have 2 double bonds. Okay? So we've got to number in such a way that gives us the lowest total numbers to both the double bonds, because those are the most important functional groups here. Okay? It's still a pent. It's still an ene, because it's got double bonds. But it's not just an ene. There are two enes. This is now a diene. Okay? But I have to number to both the double bonds in a way that gives us the smallest numbers overall. Okay? All right, let's number it from the right to start with. If I number it from the right, we get 1, 2, 3, 4, 5. If I number it from the left,
Now, you can't go.
1, 2, 3, 4, 5. So if I number from the left, the double bonds are on 1 and 3. And 1 plus 3 gives us 4. If I number from the right, it's on 2 and 4. And 2 plus 4 gives me 6. So it makes sense to number it from this end, because that gives me the lowest numbers overall. Okay? So pent, 1, 3, diene.
Why don't we just number the bonds instead of the carbons?
What now?
Why wouldn't you just number the bonds instead of the carbons?
People smarter than me figured all this out. I don't have a clue. I'm not on the IUPAC panel, so I don't know.
Would it be?
Yeah.
On
Bailey.
the first CTV, on our right, is that a 5 below it?
Yeah. Yeah, it's a 5.
Okay, so then where do you get the 1 and the 3 from? I get the 1 and not the 3.
Because the first place I encounter a carbon with a double bond on it is 1 and 3.
Oh, okay.
Got it?
Yeah.
Would it be technically wrong if you did the 2 and 4, because it's still denotes the double bond?
Well, that depends on what you mean by technically. Okay.
Would you consider it wrong?
Yes. Yes, I would count off for it if you didn't number it from the correct end.